Okay, so for number one, starts you off with just back substitution. So very first thing you'll do with number one, let me see if I can get the light. It's in a new location here, so let me see if I can get the lighting a little bit better. Maybe that's a little bit better. We'll see. Okay, so number one, we start off with the end of it. We've got negative 5w is equal to negative 15. So just dividing those two things, we get w equal to 3. And then once we've got that one solution, we'll take that solution for the w equal to 3 and then plug it back into the line that's above it. So we've got z plus w is equal to 2. So that's z plus 3 equals 2. Solving this one, we get z would equal negative 1. And then using those two values, we can go into the next equation that's here. So negative 3y minus 18z minus 6w equals negative 24. So the w is equal to 3. The z is equal to negative 1. And we'll solve that one out. So that's going to be a positive 18. That's going to be a positive 18. So that is negative 3y plus 36 equals negative 24. Subtracting 36. And then dividing those two, we get y is equal to 20. Okay, so now we have those three values to plug in at the end to go from there. Sarah, question?
No, actually, I think it should be negative 18.
Oh, you are correct. Yes, right there.
Negative 3.
Yeah, so negative 6 times 3 would be a negative 18. Yep, you are correct. So that would actually be 0. Thank you for catching that. So that's negative 3y equal to negative 24. Okay, so that would be y equal to 8. Thank you for catching that. Yes, that was negative 6 times 3. That would have been a negative 18 there. Sorry about that. I forgot my reading glasses, so trying to pay attention. I missed that one little sign there. All right, and then the last one, we've got negative 4x. Going back to this top equation that we had here. So we've got negative 4x minus 8y minus 2z minus 6w equals negative 3. And we're going to plug in those values from back up here that we had w equal to 3 and z equal to negative 1. So just go back and plug in all of those numbers there. Okay, so that is negative 4x minus 8. Be careful with my signs here this time. That's an 8 minus 2 times negative 1 minus 6 times 3. That's going to be a negative 64, positive 2, and a minus 18. Okay, so negative 64 plus 2 would be negative 62. Minus 18, that's going to be a negative 80. adding 80 to both sides. It's negative 4x equal to 77. And dividing that out, that's not going to come out to be a whole number. In that case, you should be allowed to just leave that as negative 77 over 4 because that will not simplify for anything. So that would be your x value. So this one is basically an ordered quadruple, I guess you'd call it. We've got our x value is negative 77 over 4. Our y value was 8. Z was negative 1, and our W value was 3. So that would be in X, Y, Z, W order to plug in the answer. Okay, easy question, but that one, there's so much work to go back and plug back into on those. It's a, easy question, but it's a little bit time consuming to get there. All right, question 2. Definitely a lot quicker on question 2. Because with question 2, it simply says, here's this ordered pair. Is this a solution to this system? So all we have to do is take the 5, 3 and plug it back in and see if those things are actually equal. So for number 2, we have negative 6x plus y equal to negative 27. And we're basically going to plug in this for x and y and see, does this equal negative 27 when we plug it in? So it's negative 6 times 5 plus 3. Does that equal negative 27? Negative 30 plus 3 does equal negative 27. So that first part of it's a yes. Okay, but we also have to check it for the second equation, 48. Okay, so we've got 9x plus y equals 48. So same thing, plugging in the 5 and 3. 9 times 5 plus 3, does that equal 48? Just 45 plus 43 equals 48. Yes, it does. And if they're both yes, then the answer is yes. For if it's a no answer, if either one of these two winds up being no, then it's not going to be. So it has to make both equations true for the system that you're working with. Okay. Number 3 says determine whether the given matrices are inverses of each other by computing their product. So we have 1, 1, 1 is matrix A, 4, 3, 0, 4, 5, 4, and we're going to multiply that by matrix B, 0.25, negative 0.75, 0, 1, and negative 0.25, and negative 0.25. I wish that would have been a little bit better numbers here on that last, but we'll make sure that we're going to get that way. So basically, here's what we're asking is if we multiply A times B, does that equal the identity matrix? Okay, so we're basically just going to multiply this thing out. And I think for this question, it is a yes and no answer, but you also have to put the product of what that number is going to be. So I think you probably will get partial credit on this one, depending on what it goes. So for these, what we said we're going to do anytime you're multiplying matrices is you have to multiply the rows by the columns. With these being all ones, it makes it really easy because if we do row 1 times column 1, it's going to be 3 plus negative 4 plus 2. So that one so if we do row 1 times column 1, again, this one works out fairly nice because it's 1 times 3 for 3, 1 times -4 for -4, and 1 times 2 for 2. So that's 3 minus 4, -1, and -1 plus 2 is 1. Okay, so we'll go ahead and put that answer right here just to see what happens. All right, then we're going to do row 1 times column 2. So that will be everything here. So we're going to do 1 times 0.25, which is 0.25. I'm actually going to go up and down on these instead of side to side like we're doing here. 1 times 0 will be 0, and 1 times -0.25 is -0.25. If we add all that together, that does come out to be 0. Okay, and then the last one, we'll go back here. And again, with it being all ones, we're basically just going to add these numbers together and see what we get. So that's -1 plus 1, so that does come out to be 0. Okay, so row 1, we're in good shape. So far, so good. We'll do the same thing with row 2. Now we're going to do 4 times 3. So doing 4 times 3, that is 12. 3 times -4 is -12. And 0 times 2 is 0. Put all that together, that comes out to be 0. Okay, 4 times 0.25 would be 1. 3 times 0 is 0. 0 times anything is 0, so that comes out to be nice. That's also going to be a 1. And then column 3, we have 4 times 0.75, which would be -3. You have 3 times 1, which would be 3. And then we have 0 times anything, which would be 0. So that comes out to all be zeros. So far, so good. Looks like it's going to be an identity matrix. We've got to check that last row just to make sure. And then for the last row, I'm going to put this on the side. We're doing 4, 5, and 4 times 3, -4, 2, 0.25, 0, -0.25, -0.75, 1, and -0.25. Okay, so for that last row, we did row 3, which was 4, 5, 4 times these. So we have 4 times 3, which is 12. 5 times -4, which is -20. And 4 times 2, which is 8. That's negative, that is 0. Okay, and then row 3 times columns 2. 4 times 0.25, that is 1. 5 times 0 is 0. And 4 times -0.25 is -1, so that comes out to also be 0. And then the last one, which probably is going to be a 1, we've got 4 times -7, or -0.75, which is -3. We have 5 times 1, which is 5. And then 4 times -0.25 would be -1. That's 2 minus 1, which would be 1. Okay, so that one does come out to give us the identity matrix. So they ask, is this thing an inverse? By checking the multiplication, yes, it is. And again, we get our identity matrix that we had back up here. And again, you can kind of see the identity matrix here, pulling it down. There's the 1, 0, 0, 0, 1, 0, 0, 0, and then 1. So if you kind of work these out in that same manner, and if you do, row 1 times column 1 and put that answer here, row 2 times column 2 and put the answer here, you can see the matrix there if you go back and circle the numbers to kind of give you that layout. Okay, so number 3 basically was just, well, two things. Number one, you're seeing what the answer is, but really it was just doing a multiplication problem. And then basically the answer was, all right, do your multiplication problem. Does this thing come out to be the identity matrix or not? So they're really having you work on multiplication. And then the second thing is they're saying, all right, does this give us the inverse answer or not? So. Okay, number 4. Basically the same thing as number 2. So we'll just kind of skip over number 4 because this one gave us the order pair here. You got the 2 equations, and just go back and check and see what that would work out to be. Again, you've got the answer sheet that's there, so you can go back and check and see if you have the correct answer. All right, number 5. That one we actually get to do something a little bit different with number 5. Number 5, we have 2 matrices, 9, 9, 11, -3, and -3 and 1. We're going to subtract that from 6, 6, 8, -6, and then -6, -2. Okay, so we're just going to take it one piece at a time to get our answer here. So for the first corner, it's 9 minus 6. Which equals 3. Top right hand corner, same thing. It's still 9 minus 6 for that one also, which would be 3. We have 11 minus 8 when we get to the second row. And then -3 minus -6. So 11 minus 8 is 3. -3 basically plus 6 for that one, which would also be 3. Kind of all be 3s here. Bottom row, we've got -3 minus -6 again. So we just did that one. We know that one's also 3. And then the last one, it's 1 minus -2, which is really 1 plus 2, which is also 3. Okay, so for that one, I had the 2 options A and B. It does exist because everything matches up. So the answer was 3, 3, 3, 3, 3, 3. Okay, a little odd that it came out that way, but I guess that's their idea of a little joke, a little sense of humor there for you. Okay, number 6. Let's see what we have on number 6. All right, number 6. This time you have a system that says to solve it by substitution. And honestly, on this one, just because it says that, it's asking for a solution. For me, honestly, on this one, I would actually solve this one by elimination. And let me show you, because this one, now you could solve this one for y quite easily and plug it back in, but anytime you've got these values, everything is lined up, and this one is just a y value, it's going to be really easy to solve this thing by elimination. So even though it says substitution, I'm going to go elimination just because to me, it's going to be easier. And if you want me to show you the substitution, I'll show you that one real quick. But I'm going to be honest with you. I'm going to show you what I would do if this were me. Okay, so we have 2x minus 2y equals 5, and -3x plus y is equal to -4. Okay, so here's what I'm thinking on this one. Because all we have to do is take this equation and multiply it by 2. We should have a fairly easy equation to solve with, because now you've got -2 and +2. So those two are going to cancel each other out to get 0y. So that's gone. This is just 2x minus 6x for -4x. And this is 5 minus 8 for -3. Okay, so then we just divide these two numbers. So x would equal 3/4. Okay, and now that we've got 3/4, we can take it and plug it back in anywhere here. I'm gonna go to this one. It might be because this is just y, maybe a little bit less work to do here. So then taking this 3/4 to plug it in for x here, it's -3 times 3/4 plus y equals -4. So that would be -9/4 plus y equals -4. We're going to add the 9/4 to both sides. Okay, and doing that, we get y is equal to -4 plus 9/4. To get a common denominator for this one, basically this is 4/1, so we need to multiply both of these numbers by 4. So putting that together, that is a -7/4. Okay, so final answer in ordered pair form would be 3/4 and -7/4. All right, now if you were going to do substitution, you'll still get the same answer. So for this one, this is what I would say with elimination. That to me, that would be the best way to do this one. And really, well, substitution will still work. It's probably about the same amount of work. It's just a little different variety. So let me show you the elimination on this one. Show you substitution instead of elimination for this one. Okay, so for substitution, we're going to take this equation, we're going to solve it for y. Okay, and if they're going to have you do substitution, there should always be one variable that has 1 as a coefficient. If not, then it doesn't make any sense at all to do substitution. So for this one, to solve for y, we're just going to add 3x to both sides, and we're good to go. Okay, and then we're going to take this 3x minus 4 and plug it into the other equation for y. So that'll give us 2x minus 2 times 3x minus 4 equals 5. Now, here's why I would say that if you can avoid doing substitution, to do that, because most people are good here, but there's always a chance that you may forget to do, most people do -2 times 3 to get -6, but there's a good chance that somebody's going to forget to do -2 times -4, that they will write that as just -8 and not +8. So that's why I kind of like doing the elimination, because with substitution, you always have to do some distributive property, which means there's a chance that you may forget a sign along the way. And then we subtract the 8. And then we're right back to the same answer that we had here, if we were doing elimination. But to me, we got this answer a lot faster here. That one we multiplied by 2 and then just added and subtracted. This one you had to solve it for y, plug it in, do distributive property, and then solve for x, and then you finally got this answer. To me, you get this answer, this first answer, a lot faster doing elimination than you do substitution. So now, again, you can do it how you want to. To me, that's when everything is lined up like this, and it's already here with a simple multiplication to do to make these numbers be positive and negative with the same number. I would do elimination. If it already had y equals like this, if they gave you a system that was like this, where you already had y equals and you could just plug it straight in, then it might be a little bit faster. Maybe, maybe not. Again, that choice kind of comes down to you and what you would rather do. So just because it says substitution doesn't mean you have to do substitution. You can also do elimination. Okay, number 7 gives you that A is 5449. B is 4, 4, negative 4, and 5. And we've got to find 4A plus 2B. Okay, so really pretty straightforward on this one. We're going to take every number in here and multiply it by 4. So 4 times 5 is 20. 4 times 4 is 16. 4 times 4 is 16. And 4 times 9 is 36. And we're going to double everything in here. 2 times 4 is 8. 2 times 4 is 8. 2 times negative 4 is negative 8. And 2 times 5 is 10. And then at the end, just going to add those two things together. 20 plus 8 is 28. 16 plus 8 is 24. 16 plus negative 8 is 8. And 36 plus 10 is 46. Okay, and number 8 is one of those where you really don't have to show any work because it's a multiple choice question. And it basically says, okay, here's a system of equations that we have. You just have to interchange equations 1 and 2. So all we have to do is just swap these two where the bottom ones will stay the same. So the top part needs to be x minus 9y minus 3z, which is not there. Obtain an equivalent system by performing the stated operation on the system. Interchange equations 1 and 2. I don't see. It's almost like there's a typo because, I mean, it would have to be A, but A is missing the 9y that should be here. So it's almost like there's a typo. There should have been a negative 9y here because we got the 4x minus 9y plus 3z. Yeah, it's got to be A, but there's a typo. This value right here got left out from what was here because that's the only way that it could work because you have to put interchanging 1 and 2, the x value needs to be first. So, yeah, it's A, but there's a typo there because this value that's here is not here, but it's got to be A. That's the only option it could be. So, okay, and looking through this the other day, I didn't catch that. I just saw the x first, and I just kind of went with it when I was going through these. All right, and again, if something like that happens on the test where you're pretty sure what the answer is, but you're like, is that a trick question? Just let me know. Just shoot me an email and say, hey, would this happen? And just want to make sure this was what the correct answer was on this one. Can you check that for me? Because I can see how that could throw you off just a little bit because, there's not a correct answer there. So that would have to just be your best option to put A. All right, number 9. Here's where we get through the word problems. And again, there's a couple of word problems set up here. So for number 9, we have you drive truck company, $14 million on 260 new vehicles. Each van will be $45,000. Each small truck is $70,000, and each large truck is $60,000. Odd that those are more expensive for the large truck, but that's what it is. Past experience shows that they need twice as many vans as small trucks. How many of each vehicle type do they need? Okay. So first thing on number 9. All right, let's get our values we have here. It says we need 260 vehicles. Yes. So we've got x plus y plus z equals 260. And again, we'll go x is vans, y is a small truck, and z is a large truck. Okay, we have $45,000 per van. That's an expensive van. $70,000 for the small truck, which is also very expensive. And together they're going to spend $14 million on all those vehicles. And the first thing I'd be questioning is why we're paying that much for all the vehicles. But anyway, and then at the end it says we need twice as many vans as trucks. So if we double the small trucks, that should give us the volume of the vans. Okay, so there's our three equations that we're going to do. All right, now, and then here's something we're going to do a little different than when we did it in class, because I just, as I was going through this one, it popped in my head. I was like, why did we do this? Because these are all huge numbers that we have here. So the very first thing is, let's go ahead and take this equation we've got. We've got x plus y plus z equals 260. Because all these numbers are the same, that they all have at least 3 zeros at the end. Let's take this entire equation and divide it by 1,000. Because we can just go through and knock off 3 zeros off of every one of these numbers, and it still work out to be the same way. Just like, we could take if we wanted to get rid of x here, we can multiply this by 45,000. Or if these are all multiples of, thousands, let's just knock that off. Let's make that 45x. Let's make that 70y. We'll make that 60z. And then that would equal, instead of 14 million now it's just 14,000. So those numbers are a lot easier to work with when we start multiplying everything together. And then the last thing we need to do here is we need to rewrite this so it's x minus 2y equals 0. Okay, so that's really the system we're going to work with. Yeah, you could work with this back up here where these are all these huge numbers. But again, if you see that they all have multiple zeros at the end, you can just cancel off the same amount of zeros off of each problem and be okay. Okay, so that's what we're going to work with. Now, here's where, for these problems, the order we find these in, they would tell you that, you need to get this in descending order where we're going to have it where we have x, then we have y, and then we have z. But here's where I'm going to say that if we saw this like we were talking about in section 3, I think it was, maybe section 2, that as long as we eliminate the same variable twice, we're okay. So any of these problems like this where they've already got one variable missing, let's take these two equations and let's eliminate x. Because that way then we'll have a 2x2 system like we were solving in 6.1, which then makes the 6.3 work that this came from, would make it really easy. So you can do it all kinds of different ways, but here's what I would say. Anytime it's a 3x3 system that you have here where you've got 3 equations and 3 variables, you just have to eliminate the same variable twice, so not x. So let's eliminate z from these two equations. Because now, if we get it down to here, we can just solve this system that we have on the bottom part and we'll be good to go. Okay, so to eliminate z, we need to multiply this equation by negative 60. So it'd be negative 60x minus 60y minus 60z equals 260 times 60 is, check that real quick, 15,600. Okay. And then we're just going to add that to this equation that's here. So that's 45x plus 70y plus 60z equals 14,000. Put all that together, and we have negative 15x plus 10y equals negative 1,600. Okay, so then what we can do is that now that we've got this equation that's in terms of x and y and this equation in terms of x and y, we're just going to solve that little system. Now again, this is going to be different than the way the book would say to do it, but to me, this is an easier way that you can do this every single time when you go through these. Now we're just going to solve this system. You've really got two choices. You can either multiply by 15 to eliminate the x, or you can multiply by 5 to eliminate the y. I'm just going to go ahead and multiply by 5 so we can eliminate the y. So we've got 5x minus 10y equals 0. Negative 15x plus 10y equals negative 1,600. Negative 10x equals negative 1,600. And then dividing those two, we get x would equal 160. Okay, and x was our vance. Okay, and once we've got that first value, now you can go back and plug it back in any equation along the line. If you go back to the very first equation we had back up here that was x was equal to 2y, well, x is 160. And 160 divided by 2 means that y would be 80, and that was the small trucks. And then the easy equation from there was we had x plus y plus z equals 260. So that one was basically 160 plus 80, that was 240. Plus z equals 260, so that means that z was equal to 20. And that was our large trucks. Okay, so again, I know that's probably different in the way the book would describe it. That they would tell you would start with x and you eliminate all the x's to get negative y, and then you eliminate the y's and you go from there. You can do that, but anytime you're in a 3x3 system, now if you have 4 values, you have to do it that way. But if you have 3 equations and 3 variables, as long as you eliminate the same variable twice, that's the easier route to go with. And if they've already gotten rid of one variable here, well, now you just need to do the same thing with this equations that you have here. Just eliminate this value for a new equation, and then you can combine those 2 equations to solve that just like a regular 2x2 system. Again, I know that's not the way the book does it, but to me, that's a little bit easier way to kind of get there. Okay, let's see, number 10. Um, 10, basically the same thing as number 7. The only difference is in this case, you had to multiply by negative 4 and then add that to the 3b. So number 10, basically the same thing as number 7. So we'll just kind of skip over that one for now. 11 is a word problem. A little different word problem, so we'll go through this one and see what we have here. All right, so for 11, it says Mike took clothes to the cleaners. 3 times last month, he had 2 shirts. So I'm guessing that's 2x, well, that shirts be x. And 1 pair of slacks. So I guess the slacks are y. And that was $9.97. Then he had 7 shirts, 3 pairs of slacks, and 2 sports coats, which would be Z in that case. He paid $45.88. And finally, he bought 4 shirts and 1 coat. And that was $14.95. How much was he charged for each shirt, each pair of slacks, and each sports coat? All right, so if I was Mike, I would just look at the sign in the store. But apparently Mike won't do that. He has to do it the hard way. So we've got to figure out and solve this system that we have here. Okay, now, and again, the way the book would tell you is that we're going to, first you would have this one, so you have x that's by itself, and then you take those 2 equations and you eliminate the x, and then you have the y, and then you take the y and you solve it. So you'd have it, so you'd have something like this. Okay, which is great. But really, here's what we're going to do. We're going to do it just like the other problem. They've already eliminated z out of this equation. They've also eliminated y from this equation. So we can either take these 2 equations and eliminate z, or we can take these 2 equations and eliminate the y, so that we've already got it paired up with these. So just to do something different, because I think on the last one we eliminated z. Yeah, we did. So maybe we'll take these, and again, we could do that. We could take these 2 equations and eliminate z, and then combine it with the first equation. Just to do something different, we're going to take these 2 and eliminate y. So we're going to take the first equation and multiply by -3. Okay, so if we do that, we have -6x minus 3y equals -2991. Let me double check that number to make sure that is correct. Yep, 2991. And this equation would be, okay, just like it is. 7x plus 3y plus 2z equals 45.88. So that is that's 1x, or just x. The y's are gone, plus 2z equals 1597. Okay, so now this equation doesn't have a y. We also have this equation that doesn't have a y. So now we're going to solve those 2 equations as a system. We've got x plus 2z equals 1597. This one was 4x plus z equals 1495. Okay, now again, which one you pick? This one we just happened to decide to get rid of y, so then we could solve for z. You could have taken these 2 equations and eliminated z, and then put that together with this one. So there's multiple correct ways to get the correct answer on these, to do what you're going to do. From here, we're going to have to multiply one of these by some negative number. Let's take this second equation, multiply it by -2. That will give us x plus 2z equals 1597. This will be -8x minus 2z equals, and that should be 2990. And it is 2990. Okay, so that's -7x equals 1393. And then we're going to divide that by 7, and that'll give us that x is $1.99. Okay, and then from there, we're going to go back and plug in the different values to see what we can do. To me, that's an easy one right here to plug into for this equation. We have x plus 2z equals 1597. So x is $1.99. And then we're going to subtract the $1.99. It's going to be $13.98. dividing that by 2. Z is $6.99. And now we've got to also find out what Y is. And to me, the easiest equation to find out Y would be way back in the beginning back here, because now you have just X and Y in this value. So we have 2X plus Y equals 997. So we know that X is $1.99, so that's 2 times 199 plus Y equals 997. So that 199 times 2 is basically $4, $3.98, plus Y equals 997. Subtracting those two numbers, we get that would be $5.99. Okay, and again, back in the beginning, we said that X was the shirts, Y was the slacks, and then Z was the sport coats. Okay, so really similar to the other problem we did, it's just a little different setup as we were getting there. Okay. Let's see what we got for number 12. All right, number 12. I think one of the last big problems that we had, a lot of them after number 12, I think were a lot of repeats. But 12, I think, was the last one that was really kind of unique. We'll still go through some of those to make sure we've got them. But number 12, this one said we had a 40, and again, similar one we did in class, but this one had a little something different on it, so we'll make sure we do it here. Investment of $49,000. We had three parts. We had a 8%, 6%, and 9% investment. The total interest from those investments was $3,800. And it says the interest from the first investment was 6 times the interest in the second. Find the amounts of these. Okay, so here we go. All right, so reading through everything that's here for number 12. We've got 3 investments, X, Y, and Z, that we have $49,000 to put into those investments. Okay, the first one was 8%. The second one was 6%. And the third one was at 9%. And the money that's going to be made off of those would be $3,810. All right, now this is where it's different than what we were doing in class. It says the interest from the first investment was 6 times the interest of the second. So here's what we're going to have to do. Because we're talking about the interest amount, we're going to go ahead and do the 0.08 times X. And it says that is equal to 6 times the value of the second investment. Okay, so there's your initial setup for these. If you take those initial equations and then just rewrite them over here so that we've got something a little bit easier to work with. We have X plus Y plus Z equals 49,000. For these, I would say multiply them all by 100 to get rid of the decimals. That would make that 8X plus 6Y plus 9Z equals, we're going to add 2 zeros here, so that's 381,000. And for this one, we're going to do a couple of things. If you go ahead and multiply this out, this will be 0.08x equals 0.36y. But we don't like decimals, so same thing, let's multiply by 100 here. That's 8x equals 36y. But just to keep everything kind of lined up, we'll move this 36 over here and have that equal to 0. Okay, so this is originally what we had, just pulling out all the information from the question. taking this one and actually multiplying out to get here. We don't like decimals, so then we multiply it by 100 to get rid of all the decimals, and then just rearrange it so everything is in X, Y, Z equal to some number form. That way everything is all lined up. All right, now here's where, again, I would do something different than what the textbook would say, because the textbook would say, all right, you're good here with this one. You need to eliminate X here, you need to eliminate X here and get it down so you have Y's, and then you take these two values and you eliminate down so that you have a Z, which is great and all wonderful, everything if you want to do that. But here's what I would do. They've already eliminated Z here. So let's eliminate Z again. To do that, we're just going to do negative 9 times 0, 1. So we're going to eliminate Z from row 1 and row 2 by doing negative 1 times 9 on this equation, adding that here, and that way now we've got a 2 by 2 systems with just X's and Y's. Okay, so if we do that, that's negative 9X minus 9Y minus 9Z equals 49,000 times 9 is negative 441,000. Okay, that equation is good just like it is. It's 381. Okay, so again, the Z's are gone, which is what we want. We got negative X minus 3Y equals negative 60,000. And we can solve that with this. Okay, so now we'll take this new equation where we eliminated Z and combine that with this equation up here in the beginning that already had the Z that was eliminated. Okay, so let's multiply the top row by 8, and that way we can eliminate. And again, I'm doing that one because I know we can multiply this one by 12, but if you multiply by negative 12, you got to make sure to change some signs. So for this one, I would say let's just multiply by 8. That way this one, we don't have to change any signs. We can leave it just like it is. That would be negative 8X minus 24Y equals negative 480,000. And the second equation there, we leave it just like it is. So we have negative 60Y equals negative 480,000. Dividing those two numbers should be 80,000. I'm sorry, 8,000. So we'll knock off a 0, divide by 6, bring it back one number. So 1, 2, 3. Yeah, that's right, 8,000. Okay, and then same thing as before. Now you can go back from this equation and plug it back into either one of these two. I would say this would be the easier one to plug in. Now, well, that's coin toss. Either one here in this case is going to be fairly easy. So we'll go negative X minus 3 times 8,000 equals negative 60,000. So again, just pick one of those two equations to plug it back into. I'm going to go with the one back up here. We have the negative X minus 3Y equals negative 60,000. So it's negative X minus 24,000. It's negative 60,000. Solving this one, you get negative X equals negative 36,000. But the negatives wind up canceling, so then we get X would equal 36,000. Okay, and then to me, the easiest one from there is the very first one we had here was that the total investments was 49,000. Well, if we know that these two investments are 44,000 and our total investment was 49,000, we can just subtract those two to find out that last missing payment of Z would then be 5,000. Okay, so even though it was a little different word problem in the beginning, once you kind of got, and really it was this one little part right here to me that was one that was kind of what thrown things off. That once you had this one particular talking about interest, that the interest and that you would earn off of this amount was equal to 6 times the second amount. Well, I think once you get through that setup of that problem, everything else was really the same after that. Okay, 13. We'll get the setup on this one, and just so we don't run short on time, we may just kind of get the setup of it and kind of give you a quick rundown on this one. 13, we've got a 5,000 seat theater with 2 different ticket prices. So the big thing on 13 is that if you have the 2 different prices of tickets, there were a 5,000 seat stadium. One ticket was $25, the other ticket was $40, and then altogether that was going to get us $149,000. Okay, so to make this one, again, once you pull through the word problem, it was pretty straightforward. For this one, you can either solve for X or solve for Y. I would say just multiply by negative 25 so we can eliminate the X. Negative 125,000. So that would get you 15y equals 24,000. And dividing that 24,000 by 15, that gives the y value of 1,600. Okay, and again, if we know that there's 5,000 total tickets, and this one has 5,000, we just do 5,000 minus the 1,600. So then we know that X would equal 3,400. Okay, and again, the hardest thing on that one is it's a word problem, so you have to kind of dig through the numbers. Okay, 14. This was a 3x3 system, I think, when we set this one up. Again, I think we'll get through the setup on 14, and then after that, it was really similar to all the other problems. So we'll do the setup on this one, show you what we would do, and then kind of let you go through the rest of it from there because it's just a repeat of the other problems. But it says, baseball team sells tickets that cost $10, $20, and $30. So there's your 3 different amounts. They sold 3,167 tickets. The total ticket sales were 61,320. So for every $10 ticket they sold, for every $20 ticket, and for every $30 ticket, it would help if I would scroll that up so y'all can see it. They got $61,320. Okay, and then the last thing they kind of snuck in there said it sold 312 more $20 tickets than $10 tickets. So the $20 tickets, there was 312 that we had to add to the $10 tickets. And to me, I think that's the toughest thing is getting that. When I say that you sold 312 more of this one than the other one, so So 312 more $20 tickets than $10 tickets. So we had to take the $10 tickets, add 312, and that would give us the total of the Y tickets there. Okay, so for me, again, here's what I would do for this one. Take this last equation and rewrite it so that you have X's and Y's in the number. So just, bring that X over here, so make it negative X plus Y equals 312. We have the 10X, the 20Y, the 30Z equal to 61, 320. And then we have X plus Y plus Z equals 3,167. I would do this one just like we were doing on the other parts. That the way this one's written, they left Z off of this part. Just take these two equations here and eliminate the Z again. So you'd have to take the top equation, multiply it by negative 30 to eliminate Z. Well, when you do that, now you're going to have an equation that's got X and Y, and then you'll solve that system along with this and kind of go from there. So if we'll do this one step here, we'll have negative 30X minus 30Y minus 30Z equals 3,167 times 30. 95,010. It's negative, and we're just going to add that to this amount that's here. Okay, so it'll be negative 20x minus 10y equals 33,690. That was a negative. So now that you've eliminated eliminated z out of this equation, now you can take this equation, solve these two equations just like a regular 2x2, and then you can keep doing back substitution from there. So it's still that same thought process of if they give you one equation that's got a variable eliminated like this one did, that they did not use z at all for this one, well then take these other two equations you have, eliminate that variable that's missing here, and then solve that system just like a regular 2x2 system that we normally would do. Okay. And again, the answers are listed on that review on the sheet, so then you can kind of check it from there. But to me, that's what I would do on that one to kind of get through that same setup. Still, after that, everything's the exact same as the other couple of problems we've been doing. So just so we're not repeating the work over and over and over, we'll kind of slide by that one. Okay, 15. Finally get to something a little bit different. Because with 15, we have the matrix that's at 7, 3, 5, 7. It says find the inverse. So to find the inverse, we're going to set this to 1, 0, 0, 1. And then we're basically going to undo everything here that we can possibly do to make it so that the left side is this identity matrix and the right side becomes whatever. Okay. All right, this one's going to be not so pretty because of the fractions on this one. So very first thing we're going to do is we're going to divide this top row by negative 7. Sorry, divided by 7. So that would be 1. That would be 5/7. This will be 1/7. That will still be 0. Okay, and then we're going to take the top row, multiply it by negative 3, and we're going to add that to row 2 for a new row 2. Okay, so multiplying everything by negative 3, that is negative 3, negative 15 over 7, negative 3/7, 0. And we're going to add that to row 2, and that's going to be our new row 2 that we'll have here. So we get 0, 7 minus 15/7. Well, that's going to be 49 over 7 minus 15 over 7. I could have made this a little easier on us. That is 34 over 7. Ooh. That will be -3/7, and that will be 1. Okay, so that part's not too bad. So we have 1 5/7, 1/7, and 0. This is going to be 0.34/7, -3/7, and 1. Okay, now we've got to make this number out to be 1, so we've got to multiply by the inverse. We've got to take this and multiply by 7/34. Wow, it's going to be lovely. So still 0, that's going to be 1. Luckily, the 7s will cancel here when we do -3/7 times 7/34. The 7s will cancel, then leave us with -3/34. That's going to make that 7/34. And now we have to take and make this number cancel this number. So now we're going to have to multiply row 2 times -5/7 and add that to row 1 to get a new row 1. Okay. Okay. So that's going to be 1 5/7, 1/7, 0, multiplying row 2 by -5/7. Wow. That is 15 over. Yeah, they could have made this a little nicer. That's 50 because nothing cancels here. That's 15 over 34 times 7. It's 238. -5/7. Now this would be okay because the 7s will cancel. That'll give us -5/34. Okay, so the numbers aren't bad because that'll go to 0. The hardest thing is going to be, so we add these together, so that's 1, that's 0, that's -5/34. The hard part is just figuring out what this number is going to be. So that is 15 over 238. We're going to add that to 1/7. Well, to get this one, to get to 238, we had to do 7 times 34. So this is also going to be 34 over 238, which means this is going to be 49 over 238. Since 34 times 7, yeah, that's a lot of work for your fractions here. To get to 238, you multiply by 7 to get this one. Well, 49 would be 7 times 7. So in this case, you could divide both of these by 7, which would leave you with 7/34. Wow, that's a tough one. Okay, so our inverse was, so this is our new row 1, so it's 1 0, 7/34, -5/34. And our bottom row was still here, was good. It was 0 1, -3/34, and 7/34. Which means that this was our inverse matrix. Well, I could have thrown you a whole number in there somewhere. Yeah, that's a tough one. Okay. Good news is 16 is just a regular elimination problem, so there's not anything tough on 16. It's just a regular 2x2 system. So that one we don't have to worry about it because it's just a very easy, straightforward problem that you have to do there on 16. 17, I think on this one is also very straightforward. It says to make row 2, you just do -3 times row 1, add that to row 2. So that's just a regular rewriting equation type problem. So Row 1 will be the exact same. Row 3 will be the exact same. All you have to do to make row 2 is do -3 times row 1 and then add that to row 2. So this is just doing regular order of operations on this one. So row 1 will be the same. Row 2 will be the same. This is the only thing that will be new, where you'll do -3 times row 1 and that to row 2. So this will be the only thing new you'll have to do there for number 17. Okay, 18, just multiplication of a regular 2x2 matrix. So we're good there. So that's just row 1 times column. We'll do the 18 real quick. That'll be the last one that's kind of laced a little bit different here. So 18, we're doing those two matrices multiplied together. So we're going to multiply 2, 6 by 1, 0. So 2 times 1 is 2. 6 times 0 is 0. So that is 2 plus 0 is 2. So our first corner answer is going to be 2. Then we're going to go row 1 times column 2. Okay. So from there, that's 2 times 0 is 0. 6 times 1 is 6. That's going to be 6. All right. Now, here's the thing. If you notice on this one, and here's kind of the trick on this part. If you multiply something by the identity matrix, you're just going to get the identity matrix back. So you could go through and do all the multiplication on this one, but I think this is more like a trick question that they wanted you to kind of see that if you do anything times the identity matrix, you're just going to get this original matrix back. So you could go back through and do the same thing for 1, -4, multiplied by 1, 0. So you have 1 times 1 for 1, -4 times 0 for 0. So if you don't get this exact same matrix back, then you know that you're doing something wrong there. But I think that was kind of the hint or the trick on this one. If you multiply by the identity matrix, you're just going to get this original matrix back. Okay, 19, that was a similar one that we did earlier, just different numbers on that part of it. And then 20, that's the 3x3 systems that we've been doing. We've done 3 or 4 of those that came out of a word problem. And just remember that when you do this one, I would say, you eliminate either X or Y or Z twice. And to me, I think it would be really easy to eliminate Y, because this one, if you put equation 1 and equation 2 together, this will knock out the Y just by adding them together. And then the second time, I would do equation 1 and equation 3, because again, that's negative and positive. Those two things will knock out and go from there. So, all right. Any thoughts or any questions? I think that's about it.